Good morning, good afternoon, everybody. This is your Friday HSM Hangout. My name is Jordan Roberts, Product Specialist for the Autodesk CAM team. I am super excited today because we've got a lot of special guests. Joining us is Al Wutmo, we've got CJ, we've got Matt Pierce, we've got Wayne Griffenberg. But before we get started, we are missing one very special guest today, and I'd like to pass it over to Al just to talk about it real quick.
Hey guys, yeah, so many of you may have known that today was initially scheduled for Carl the machinist to present, but he's also Carl the CEO of Autodesk, and something had come up. So what we're going to talk about today instead is still a bit of a shop talk, but we thought we'd blend that shop talk with a topic that's very important to Carl, which is education. Many of you may or may not know that Autodesk used to charge schools for education, and it was almost a $200 million decision to say we're now going to support education for free. It's something Carl feels was a very important business decision. So we thought we'd blend the two things, shop talk and education, together, and talk about the shop at Pier 9. Our application engineer CJ has actually been helping a local SAE team where he was a member in the past. We thought it'd be a great time to talk about it because now is the time all these SAE teams are building their cars, and maybe there's some of you at shops across the Americas or even in Europe that could connect and help your local SAE teams in some way. So hopefully this inspires you to work with your local SAE teams. Obviously it's helpful helping education, but it's self-serving too. CJ was an SAE team member that I worked with in the past, got to know, and then I ended up getting to hire the best talent coming out of school because I got to know CJ working through the SAE program. So I'm going to have CJ talk a little bit about what it was like to be on the SAE team, how he thinks some of you may or may not be able to help an SAE team, or maybe it's another team, First Robotics, Formula Baja, Solar. There's a lot of these sorts of school competitions that are a great way to give back in the same way that we do, but again, it is self-serving. It gets you access to some of the best talent. So CJ, why don't you talk a little bit about, or sorry, I guess we'll let Jordan finish up his initial ramble about finding out who's on the call. I'm seeing some educators on the call here. If you have ways that you think the industrial people on the call today could help you, feel free to throw it in your comments, and I'll bring that up while it's going along. But let's get this Q&A going so CJ can both talk about what it was like to be on the SAE team and, more importantly, walk through this big car body project he did on the 5-axis router up here.
Perfect. Thanks, Al. So to get things started, I just want to ask a couple quick questions here to understand who we have. And on the education theme, we're going to ask a quick poll here. Have you ever been to Autodesk University? Do you know what it is? I've been to Autodesk. I've been Autodesk University. Been very fortunate to get to go every year that I've been an employee here, and I can tell you, hands down, it's the best event that Autodesk does from my humble perspective. And if you have any questions about how to get there, why it's important, we like to think of Autodesk University as the big event, but there's a lot of things that happen throughout the year, whether it's a high-speed machining event in your local area that you can engage with and learn a little bit more, and so that way it really kind of becomes this pilgrimage, this big event at the end. It's an awesome thing. So here, thanks for voting, everybody. We're going to close the poll, and we'll just share the results real quick so you can see. Nice distribution here. Most people on the call today are aware of what Autodesk University is, so that's really great. A couple more questions here. I want to understand how long people have been using the HSM platform. Now this includes HSM Works for SolidWorks, this includes Inventor HSM for our Inventor customers, and then Fusion, HSM technology in the cloud. So let us know, get your votes in. Appreciate the fast responses, guys. And take a look at this, pretty interesting distribution across the board. We've got some brand newbies. So for those of you, brand new, I'd also like to bring up on Wednesdays, we have these quick start webinars that are really great for people that are pretty much net new to the software and the ecosystem. Wayne guides everybody through there, and it's just a really phenomenal resource. So you want to tune in for those.
So I wonder who our level 70s were. I think I see Seth on the call. I definitely think he was a level 70. Did I see Neil Stein on the call? That must be a Neil 70 or a level 70. Thank you for joining us again, guys.
Yeah, and as we're about to, we just kicked off a brand new calendar year. Autodesk is wrapping up their fiscal year. I'm personally curious. I know Al is, and some of the other guys on the call. What's most likely to drive your growth in the future? What components of your business are you looking at to really grow and expand? If you don't see something that you're thinking about doing in the future and you'd like to share with us what your focus is, feel free. These are live, they're interactive. We've got the chat window, so you can share your social media handles and whatever you want to do. We look at all of that as well. So thanks so much for getting your responses in, guys. I'll close this and share. So take a look here. Interesting, Al. Almost 30% are in that 2 to 3 axis space, and then a lot of people are going to be really happy about some of the advancements we've done around our 4-axis capability, and then so that's just.
I see a decent percentage of people saying water jet laser plasma technology, which is interesting. If you're on Fusion, you may have noticed that we updated the kernel on that in the delivery last night. So it's good to see.
That's great. And so I think that's really all we've got right now. At the end, I'll pass it over to CJ, and then at the end of the presentation, we're gonna show you a couple of great resources, and then we also have Matt who's going to tell us a little bit more about what Autodesk education really means.
Was that the official pass off to me?
Yeah, that's you now, CJ. Yeah, we can hear you. We're not seeing your screen yet, but yeah. Okay, well, you're hearing that. I've got a couple teachers chiming in already. Lenny at ASU, they're working on an SAE team project too. Looks like the students are machining themselves there, but my guess is, Lenny, if there's some local shops that have regrind cutters or scrap material or things like that, I'm sure that can help. But while CJ is presenting, please, teachers or shops, anybody that's got some ideas for how you can help each other, throw it in the chat, and we'll make sure to plug that.
Okay, great. So first of all, what is FSAE? FSAE is a extracurricular program that goes on at colleges worldwide. SAE is the Society of Automotive Engineers, and Formula SAE is just a subsection of some of the competitions that they do. There's also Formula Electric, there's also Baja SAE. So there's a couple different competitions that go on, but Formula is probably the most popular one.
You better not say that though, CJ, because I was just thinking, Carl, who was going to do the webinar today, his son is on a Formula Baja team working on a Baja car at the engineering school.
Yeah,
there might be some.
Yeah, Baja's pretty popular too. Yeah, exactly. This is a picture of me at the Lincoln competition last year. This was the last car that I built. I had been on the team for 5 years while I was going to school for mechanical engineering, and I think about 80 teams showed up in Lincoln, and there's also a competition in Michigan, also in Germany, and I think there's one more that I don't know off the top of my head, but it's truly a worldwide event. Just at this event in Lincoln, we had teams from India, Japan, we had a couple from Germany. So it's truly a big event, and these are all students. These are 100% student-driven teams. There are alumni that come back and will help, but for judging, driving, assembling the car, it's all students. And because they're in school, this isn't their full-time gig either. They're still doing their classes, doing all the other things, so they need help, right? That kind of leads into my next point.
Thing too is that they need help, but they're also, my first job was at a university shop, so it was working alongside these students too. They're also the brightest software guys at the school because they're applying what they're learning in real time. So again, it's I can say it because I hired a graduate, CJ, who's talking now, but just a constant reminder, working with this team to get you access to these high-level students.
Yeah, and you can see on the car we have a bunch of sponsors, tons of sponsors. There's a nice HSM Works sticker on the nose cone, or close to the nose cone. And then you can see me on the right. I'm wearing my Autodesk cam shirt. So having this software is a big deal for us, especially since we actually had access to a machine shop. This is leading into my next point. What's it like being on the SAE team? Well, in the perspective of funding, to make a car takes about 40, 50 grand for this car that you see in the picture. For other teams it's less, for other teams it's more, but that is all from sponsorships. It comes in the form of written checks, it comes in the form of material, parts made, right? Some of these teams don't even have machine shops. It's very important that they get access to machines to make their parts, because if they can't make their parts, they don't have a car and they don't get that experience. I could honestly say that out of all of my classes in mechanical engineering, Formula SAE was the place that I learned the most. That's where everything got applied. You see it right in front of you. You can learn all you want about part failure and analysis and things like that, but until you see a part fail, it won't make sense.
So how many teams do you think of the 80 teams of the race I went to? It feels like there's a couple that did. I mean, tires fall off, cars don't finish. What you're saying is so true. Students put the year into it and they see the failure, and the engineering process really becomes real to these students.
Yep. So out of the 80 or so teams that showed up, the first thing you have to do is pass tech, which is they make sure your car is in compliance with all the rules, things like that. I would say about 2/3 to half pass tech. So that means, you know, 40 to somewhere between 40 and 60 teams were actually allowed to turn on their cars.
It's a real world education where you can get an answer that doesn't, you didn't get a solution, where in most schools, like, there's a right and wrong answer, but you end up in this spot where the car just didn't work, right?
Yep. And then after passing tech, you go through all of the dynamic events, and then the hardest part of any FSAE competition is endurance racing, right? Where you spend, I think it's like 20-something laps, maybe more, just driving the car around the track for your best time, right? I think only 20% of cars actually make it to the finish line, because most cars lose parts, engines catch on fire. That happens every year. A car will lose a wheel and it'll roll off into the crowd, you know, causes quite a lot of commotion. But yeah, this is truly a big lesson in a lot of aspects of engineering, and it's interdisciplinary too. We do electrical, mechanical, some programming. But yeah, it's a big deal.
I just want to throw this out there because I'm seeing a comment here from Sean. He's a mentor for a FIRST robotics team. So FIRST robotics, similar to the SAE competitions, goes all the way down to Lego League, and then it scales at the high school level into high school teams building robots that compete with each other. Similar thing. It's high school students that sometimes have access to machine shops, sometimes don't. Sean, I'm curious if your school has access to a shop. I guess through you they would. But yeah, far beyond these same sort of learning principles go just beyond SAE. So hopefully we're opening our eyes to all these cool school programs that can use our help and can actually help us by helping them.
Yep. And Cal State Fullerton had a slight advantage because they had access to me, and I had access to other shops and places and connections through Autodesk. But I continue to support the team, so I'll show a couple more pictures here. Let's get rid of that. So if you were looking at the wheels on the car, this is the first stop on the wheel center. I cut this in the shop at school. But like I said, if it's a school that doesn't have a shop, they have to send these out. I'll show some pictures from other people that made parts for SAE teams. This is going to be a tool for the carbon fiber wheel barrels. So we had aluminum wheel barrels, but we're making tools to make carbon fiber ones. That's the other side of it. This is the chassis tool. So this is me setting up the machine at Pier 9. I'll do a short demo of how I program this part in a couple minutes. But it's pretty big, and luckily we had this machine at Pier 9 so we could do the 5-axis holes that needed to go in here for suspension mounting points and such.
This is a good example of the Cal State Fullerton team. I mean, you've got access to Haas equipment, but they didn't have access to a large gantry router to do this part of the project. So even teams that have access to some machines don't have access to all the machines they need to build their projects.
Yeah, so they were in luck that they have me as a connection in order to be able to do this for them. And speaking on the commitment side of things to getting this done, they drove 8 hours in the morning to come take this up to the pier. I cut it, and then they drove back the same day, right? So when a team needs to have something done, they will do whatever it takes to make sure it gets done. They are absolutely willing. Here's a little video of what I call the new workplane dance. So the post takes care of all the positioning moves and things like that. All you have to do is give it a tool orientation. And then we also have Keith Clausen, who Al can speak a little bit more on what he does, but he helped his local team with some uprights. So he was able to use his machine to do this.
This setup is super cool, and Keith is actually on the line. So if you want to type anything in the comments, Keith, go back a couple shots, because I think it's super cool how Keith did this. This is his. It's a one setup, but this is kind of the second setup. Maybe you'd call it the third. I found it really inspiring how Keith machined this. So he put the part in. He machined half of it, but it was still held together. So maybe go back one more picture. And then he actually, no, I guess there was another picture. Then he actually machined and bolted on the fixture that held the part together and finished machining it out and then unbolted the part off. So the part never left, and it came off complete, no tabs, no nothing, completely machined the part in one setup. I thought it was very cool how Keith went about fixturing that part. And that might be an inspirational technique for some of you and some parts. I hopefully understood what happened there. He machined one half of it. Instead of taking it out of the machine, he literally bolted his fixture in there to hold it up, kind of similar to moving clamps, but it was a custom clamping setup, machined the rest of it, and took off a finished part in one setup. Yep. And again, a huge thanks to Keith, who's one of our users, and also reaching out and helping schools. So good plug, and I'm seeing some comments come in that they like your setup, Keith.
Yeah, and this is a very common type of part for these teams. This is obviously the spindle upright, but every car needs something like this, and most teams make it out of aluminum, or they'll do sheet metal, make it out of steel and weld it, but all the teams that make it out of aluminum, they need this part machined. And then one more from Mark Reese. I think he's a applications engineer at Datron. I wasn't sure.
Yeah, this is actually a picture taken in the Datron office, if I'm not mistaken, in Germany.
Yeah, so he made the wheel centers for this car on one of their machines. So this is everywhere. The teams need a ton of help. It's all student-driven. And if you're looking for talent in the area that you could potentially hire, there's no better place to look than these teams. That's kind of the end of my spiel about what FSAE is. I do have a little demo on how I programmed that chassis tool in that DMS, so I'll spend a couple minutes doing that. But before I move on, are there any questions about FSAE in general?
Yeah, I don't see any in here now, so I think what I'll just say is if people don't know how to ask questions, remember on that go-to webinar bar that you have, you might just see a little orange arrow that's got it collapsed. You can click that to pop it out. There's a question area. Feel free to ask questions, whether it be directly to CJ about FSAE, but we've had, like I said, Lenny's jumped on here. There's some team mentors for other teams, comments you want to throw in to add to the discussion. Add that in the comments, and then after CJ gives his little presentation on how he programmed this plug, 5-axis or 3+2 plug, I'll review back through the questions and try and spark this conversation and see what the rest of you have to offer to it.
Excellent. So I'm going to show that picture of me setting up the machine again so you can see what's going on. So obviously left to right is X. Along the center line of that part will be Y. And so you can see on my setup here, I made a little dot on the front center. That's going to be my work offset. And you can see all the holes that need to be put into this thing. So let's go ahead and jump in. So I'll start with the setup. And there's only one body in the setup, so it's selected the only body that's available. I'm going to set my orientation for my X and Y. I'll just say X is going to be the line. Y I'm going to make perpendicular to this face on the front. You should see Y move there. Okay, and I need to flip Y over, so I'll just hit that check mark for flip Y axis. And now I want the origin itself to snap to that point that I drew. So I'm going to set my origin to selected point and then select that sketch point. There we go. Pretty easy. I'm not going to change my stock model. It's a near net shape already. There was some finishing to do on it, but not too worried about the stock. All right. So the first operation I'll do is cut out a couple of
Sorry
holes.
for the interruption, but a quick question. Lenny's asking, is you cut this out of Wren shape?
It's high density foam, but I don't know if it's Wren shape specifically. I'll look that up later and answer that question.
Sure,
the high density foam was donated by the company. It's relatively expensive material.
A way that you can help. It might be a small piece of scrap for you that was going to be pizza party money, but it could be the piece that the FSAE team needs. So something to keep in the back of your mind. If you get some scrap bits, regrinds, that kind of stuff, it could turn into a car or a robot or something else for your local school.
Right. You would be surprised what these teams can do with just scrap material. All right. So there's a bunch of different size holes on here. There's number 10 holes. There's 1/4-inch holes, 5/16, and 3/8. So there's 4 different size holes. We'll start with the number 10 holes. So I'm going to hit the drilling operation. Make sure I have my number 10 drill selected. Okay, there's my number 10 drill. And I'm going to do all the holes in the Z-up orientation. So just a regular 3-axis orientation, so I'm not going to change the tool axis. I'm going to select the first number 10 hole. Okay, so there's one of them. Turn on select same diameter, finds all the same diameter holes. Okay, so that's easy. Click OK. Now I'm going to do the holes on this face right here, this face that's angled, and it looks like a 45-degree angle or so. So I'm going to open a new drilling operation. You need to do a new drilling operation for every tool orientation. So I'm going to turn on tool orientation and just select the Z face. Right, and you notice when I click on that face, Z now points normal to that direction. And now I can select one of the hole faces. Turn on select same diameter, finds all the same diameter holes. The clearance height is pretty tall right now. It goes way out there. I can go back and change those all at once later. Right? But if I wanted to do it for this one operation, I could just say, I'll disable the feed height. And right now it says retract height, the stock top. Right? But you can see that plane is looking all the way out there for that stock top. I'm instead just going to say from hole top 2 inches. Much better. Okay. Al, I see a lot of questions coming in here. Is there anything I need to answer?
As of right now, there's a lot of just a lot of comments.
Okay.
One person, I'll hit on them now, I guess, since we've stopped. Somebody's wondering how you find out more about FSAE, students.sae.org. And then Lenny was saying that their team and other teams have Facebook pages, many teams. So this is sort of an extension, but if you've seen a lot of the real nice machining videos that we've done for the Autodesk CAM products, we actually found the videographer as the guy who made the videos for CJ's FSAE team. So again, lots of side benefits to doing the right thing and helping education. But if you search YouTube, you'll find all kinds of great videos of what the teams have done. But yeah, no questions specifically to the toolpath yet.
Okay, great. I'm just going to continue making these holes then. So we did the ones on top, the ones at that angle. There's more at a slight angle on the right side and then more at almost a 90-degree angle. So I'm just going to continue selecting those holes down the side. So change my tool orientation. In this case, the holes are normal to just this flat face right here. So I select that face, select the holes. Super easy. Now this next face here where these holes are at almost a 90 degree angle, that face is not flat, it's actually convex. And so I won't be able to select that face for the tool orientation, but here's what I can do instead. If I go to geometry, turn on tool orientation, can't select the face, but I can select the hole itself. When you select the hole, it makes the tool axis parallel to the axis of the hole, right? So no, it is normal. I just need to check my Z direction. It is facing the opposite direction, so I need to flip Z. And now I can select the face of the hole to drill. Turn on select same diameter, finds all the same diameter holes. Super easy. All right, now I just need to do the other side. And you notice I can select the drill operation from the top, but I could also just duplicate the drill operation and then choose the settings from here. Because let's say you had your drilling cycle set up with specific pecking depths, or you had your feeds and speeds right, or you had your heights right. You could just duplicate the operation and then select the new geometry. Okay, so there's that side there. Duplicate that one.
So I follow you on Instagram, CJ, and when you were making this part, I remember seeing two pictures. One where you had the part mounted to the table, and then another where you were mounting the part to the table again. And I'm imagining it's because of these holes where you realized that you actually had to raise the part up off the bed so that the head wouldn't run into the table. Was the holes the reason?
Yes. So initially when I put this into the machine, we had this mounted on a big piece of plywood, right? It was just, and it was much wider than the part was. If we wanted to do these holes on the side, the spindle would have smacked right into the table and onto that piece of plywood. So I had to unmount it from that wood. There was exactly 20 screws put up into this thing, so I had to take it off the plywood. Then we put it up on risers and actually put it backwards in the machine. So there was some finagling putting it in there.
I think it's worth mentioning because we talked about Keith's creative fixturing for how he machined that upright part. When you're doing these big parts on routers, you're often putting them up on risers to hold it up off the table and get you clearance.
Yeah.
Again, sorry for the distraction.
No, that's okay. Please make comments all you like. It kind of breaks up the monotony of just watching me program. So these holes in here, when I did this operation, turned on select same diameter, it didn't find these 3 holes back here. And that's actually because those are at a different angle. I think they're angled up about 1 degree from these other holes down here. So I do need to make an operation to get those ones in there. So I'm going to select that hole right there, and then choose that to cut. And there we go. So now all the number 10 holes are programmed. And if I was really wanting to make sure I was organized, I can go back and name all these operations. And like I said before, when we were changing these front angle clearance heights, I could actually go back and change all these operations at once. So I'm going to highlight them all, right-click, and select Compare and Edit. Okay. So now this window is editing every parameter in all of the operations at once. Right. So I know that my feed height I want to disable. I just want it to go down to the height and start cutting. So I'm going to go to feed height. I'm going to make sure they're all disabled. So I say Edit All Disabled. Now they're all disabled. And I'm also going to look at my retract height. I want this to be relative to my hole top, and I want the offset to be 2 inches from the hole top. Okay, it's going to ask me if I want to change them all. I do. regenerate the toolpaths, and now you can see every one of my operations has changed to have a 2-inch retract height from the top of the hole.
CJ, I'm glad you showed that, and I don't know that we've showed that in one of our recent Hangouts. So maybe we should reinforce what just happened there. I was able to select a series of operations, go back into Compare and Edit. So when you select a series of operations, Compare and Edit in the top of the right-click menu, you now get this Excel-like graph that's showing you all of the parameters across all of those operations. You can search for specific parameters, you can filter the parameters, many things from here. So you might even do something like just looking what's different across the operations. The other thing you can do from here, so this is just another little tidbit, because I've had some people ask in the past, how do I change my defaults for things that aren't a numerical input? You know, I'm sure everybody knows you can right-click a numerical input and change your defaults. But if you right-click a drop-down, like you want to default all your retracts from model top 1 inch up because you like this tool to stop an inch above your model every time before it comes down, you can change any drop-down or checkbox default from within this Compare and Edit dialog. So I'm glad you hit on it. It's a bit of a distraction, but a couple neat things you can do in Compare and Edit if you're not using Compare and Edit today. Of course, this is in all 3 of the HSM products.
Yeah, this is probably one of my favorite tools to use because, like you said, if I want to adjust coolant, maybe I just type in coolant, shows me the coolant settings. You can change anything you want here. Cool. So there's all the number 10 drilling operations. There's a couple more drilling operations, so I'll just go ahead and do those. There's a 1/4 inch drill on top. There's no tool orientations for these next ones that are coming up. But you notice that when I select the correct hole and then turn on select same diameter, it only finds the holes that are truly the same diameter. So I don't need to worry about extra holes being included or having to go find other holes that were excluded. All right, same for the...
CJ, you just made Lenny's day.
Oh, really?
And I think Lenny's been a user, if I'm not mistaken, prior to Autodesk acquiring HSM Works. So using it 3+ years, and you just taught him something. So good. Thanks for mentioning it out.
Learn something new every day.
Yeah, we all learn something new every day, don't we?
All right, finally I'll do the 3/8 hole right there. Okay, so I've done all the drilling on here, and I'm going to organize some of this. All the number 10 drilling operations, I'm just going to stick those in a folder for organization. So I'll highlight those guys, right-click, add to new folder, and I'll call this folder number 10 drilling. All right, so now I've got a nice way to organize my operations. The last thing I'll do on here is do some 3D parallel operations on these side angles faces here. I don't know if there's a technical term for that, but they're angled and they're on the side. So I'm going to go 3D parallel and select a ball and mill for this one. Okay, and I do want the tool orientation to be normal to these faces, or at least to one of them. So I'm going to turn on tool orientation, select that face right there for my tool orientation. You'll see Z becomes normal to that face. And for the machining boundary, it's going to be a selection. And I'm going to select one edge. And you'll see when I select that, that's not quite the entire area that I want to machine. So I'm going to click it one more time. And now I can adjust where this boundary is going. So I can take it all the way out to this edge here. I can also change the boundary to go over this fillet, also on the other side. It's kind of like the Google Maps suggestion where you can drag points on your map and make sure that you're going to all the correct places.
And I think we should slow down on this one too, because this is another concept that is important, and I don't know that we've covered it on one of our Hangouts recently. So what we've done is when he made his initial selection, we made a decision on what chain you wanted to do, and that's easy when it's a closed loop, but that automatic decision-making process gets a lot harder when you get to what we would call a Y-intersection. There's 2 ways to go, and we have different algorithms based on if you're in a 2D pocket or a 3D parallel. We have sort of a better way of guessing, but we get it wrong. And so what he did is you selected it a second time, and that put you into an edit mode. I love the Google Maps analogy you use, CJ. Think of it like I'm going from here to Portland, but I want to stop by Starbucks for a coffee on the way. You're adding those waypoints to your route to make sure you route through there. Again, I'm super glad that you've covered this, and hopefully that's another trick that's helpful to the people on the call. And for those that joined late, what CJ's programming is a plug for a FSAE car mold that was cut on a 5-axis rotor.
Cool.
Thank you,
Excellent.
CJ, again for showing
this.
Wow.
So now I've got the correct boundary that I want, right? So there's this little selection set of buttons that pops up, and I want to click the green check to make sure that I accept the contour. There is a common little mistake that people make. They'll go ahead and click OK, but that doesn't save the contour. You need to make sure you click the green plus. That saves the boundary, and then you can go back and adjust whatever you need to about the toolpath. Click OK, and there's a parallel operation. Okay.
So we have a question from, is it a user wondering, can we simulate the full machine? In our HSM Works product today, we do have machine simulation. We don't have it in Inventor HSM and Fusion, but there is a little bit of a trick. If you take your tool holder, what many users will do in the meantime is model the tool holder, a large upper diameter on the tool holder that's the size of the head, and that now gives you collision checking against other things. The beauty of it is if you use shaft and holder detection, the toolpath will actually calculate a toolpath that avoids that even hitting anything. But the reality is the only way to do it now is to cheat it in the definition of your tool holder. It is on our roadmap. Don't expect to see anything in the next 6 months. But yeah, we don't have that today.
Cool. So for this particular part, those were the only operations that I needed to do to complete it. And like I said, the guys from the team were ecstatic that I would do this for them because they had no other way to do it. They drove a total of 16 hours in 2 days to make sure that this got done. So it was a big deal for them.
So we have a great suggestion from Dave, and Dave, you're absolutely right. What Dave is suggesting is maybe do the tool orientation not directly perpendicular to that surface, but instead off angle by 15 or 20 degrees so you're not cutting with the tip of the ball. So that's a great suggestion. Cutting with the tip of the ball, you're at the center of rotation. It's not rotating as quickly. It's not at the very center. It's not even turning. So you could do that. Yeah, you could
Yep.
do the tool orientation not completely perpendicular to that surface. Excellent suggestion.
Yeah, I could even just, for example, duplicate that operation, and I'll just turn off the tool orientation because turning it off will make it at a nice angle to cut with the side of the tool there. And you can see it's the same operation, just the tool orientation is different. And that can be based off of planes, it could be based off of edges, so it would be parallel to the edge, things like that.
So CJ, I see some other projects there in Fusion. What are those for? An operator, you're getting ready to do some of those later?
Yeah, so these I'm really excited about. The materials being shipped to Pier 9 right now. These are more uprights, so just like the part that Keith did. And I'm going to be cutting these on our new machine at the Pier, the MX330, Matsura MX330. So this will be a lot of fun to do. I'm really excited about these parts.
Good. So if you're not following CJ on Instagram, you'll probably get a live feed of what's going on as he sets up to machine those parts on Instagram. So I think maybe what a good thing, were you done with showing your software tips and tricks, CJ?
Yep, that's it for
me.
me.
The two biggest takeaways beyond just sort of seeing how you approached the part, yeah, it was a simple part, but I thought it was nice to show it because oftentimes people think 5-axis and immediately get scared and, oh, these are big hard problems. I saw a lot of people say their business is going to change with 3+2 machining. So I think it was nice that you showed that 5-axis machining allows you to access different sides of the part. Doesn't have to be complicated problems. I love that you showed compare and edit. There's a bonus that we taught Lenny something. Hopefully some of you got something out of the chaining. So now maybe what we'll do is transition over. We've got Matt Pierce on the line, who runs the education program and can answer some questions there. While we're transitioning over to Matt, I see a bunch of questions regarding curriculum. So I'm going to give a plug to my friend Titan Gilroy. If you haven't seen Titan's content, it's academy.titansofcnc.com. Any teacher can register for that. Jordan, maybe pull up that webpage and we can show it at the end. He's got some amazing projects that are really well thought out in regards to using standardized tooling and standardized bits of material, some nice prints to follow along with drawing them, and he's working his way through the process of having video content you can follow along with. So if you haven't seen that content, that's a great bit of content to leverage as a teacher.
That's a great point, Al. It's a really, really great point. So, Matt, are you on the line? Do we still have you?
Yep, absolutely. I'm here, ready to go. Thank you for the opportunity to talk to everybody. Like Al said, I run our education programs, and one of the things that we try to do, we have a lot of resources available to schools, to students, to mentors, to anybody that's involved in the educational process, and our goal is really to make those things as accessible as we possibly can. It's not always practical for the people on our team to fly everywhere and meet with people in person, so the second best thing we can do is put those things on the internet, and it starts with the free software.
And I do need to mention something. We did release HSM Works 2017. There has been some delays in getting that particular product onto the education site, but we're actively working on it. Hopefully by the end of next week that's done. I saw Lenny asked a question about that.
Okay, good. So it starts with the free software, and that's a big step. Like Al mentioned earlier, it's a hurdle for a lot of people, but it's not the only thing that we have. So we're actively working to compile other resources. Al mentioned curriculum stuff that Titan's doing. We also have another project to create curriculum content that'll be maybe a little more comprehensive than what Titan has, and it's targeted more towards community colleges and people like that. It's very hands-on, and those modules will start to be released in the next few months. We have student expert programs, so depending on what your needs are, if you're a commercial user of software and you're looking for talent, we're happy to connect you with students in your area that are already deeply using some of our tools, specifically HSM products. And then we do have people who are supporting schools directly, like Lenny at Arizona State. We have a guy on our team who lives in Phoenix. He used to teach at Arizona State, so maybe that's an area where we have a good match. And I guess I would start by just throwing out my contact information. It's matt.pierce, P-I-E-R-C-E, at autodesk.com. And I would say if people are listening and they have any interest or they want to follow up, don't hesitate to send me an email, and we'll get you connected with the right resource to help you in regards to education. So maybe I'll stop there and see, are there any questions or comments on the line right now?
I think we might be good, and if any questions come up, we'll just follow up with those offline. So, and guys, if you have any issues getting in touch with Matt, he's a great guy. Education's at the core of my personal interests here at Autodesk. I just absolutely love helping these guys out. So anything that the extended team can do to help out your students and your educators, we will bend over backwards to help out that community. So Matt, thanks so much for joining us. Sure. And guys, matt.pierce@autodesk.com if you have any questions. Real briefly, I'd like to go through a couple other places that are education related. We've got the Autodesk Knowledge Network, so if you guys don't know about this platform, just go out into your browser right now and bookmark this thing, knowledge.autodesk.com. It is phenomenal. I get a ton of questions every week, and a lot of times they're the same questions. And if I don't ever know the answer to the question, I might even come in here myself and type it in and find out the answer. And you guys can certainly do this on your own as well. So just a phenomenal resource, and we want to make sure everybody knows that this exists and that you're not on your own. We've got a ton of online self-paced learning resources that you guys can take advantage of, and there's a great community around all of our products, which is really one of the things that makes these technologies so special.
Hey Jordan, quick question here since we've got Matt on the line today, and I apologize for being on the spot, Matt. I had a friend that actually went through this. There's somebody on the line who feels inspired. They want to help a local FIRST Robotics team. They don't have a .edu email address. How do we get them copies of our software so they can help a school for the educational purposes? Is there a process for that?
Well, that's a good question, and you don't need an EDU email to access the website. So that was a requirement.
Honor system. You can use any email address you want and use it appropriately. Is that what you're saying?
Yeah, exactly. And there was a requirement many years ago that had to be .edu, but we found that was too restrictive.
And I think what you're seeing with the general Autodesk policy, whether it be Fusion allowing startups and enthusiasts to use the product for free, or education getting access to the software in general, we have tried to be very liberal to get the tools in people's hands so that they can use it, right? We're not
exactly
artificial barriers.
Right. The spirit of what we're trying to do is to help people. So we'll all, and if you do ever run into a problem, ping me. We'll find a way to get it to work.
Hopefully that answers your question, Jonathan. If not, feel free to ping us one of us after the webinar.
Great. Yeah, and we've got these two spaces that are amazing, so you guys can go out to Facebook and engage with the Autodesk Build Space in Boston, right there. Just do a quick.
By the way, I cannot say enough good things about this space. I went there by accident. I was supposed to go over to the former Delcam office. We have a shop over there this past week, and we ended up just past Labrador, out over the ocean, and the pilot came on and said something was leaking, and we'd be turning around. Just before we landed, they told us not to be alarmed by the fire trucks on the runway, but that was fun. Anyway, I ended up back in New York and thought, well, I'm on the East Coast, why don't I head up to the Boston office? And it is an amazing facility. If you're in the area, it's open to the public on Tuesdays and Thursdays. You can sign up for a tour. Highly recommend checking that place out. They've done a phenomenal job building a workspace that's got some state-of-the-art technology in it.
Yeah, and while you're trying to not take a swim in the Atlantic, and learn more about what Autodesk is doing inside the community, you guys can come here. You can go to autodesk.com/build-space, and you can again learn more about the community. You can even apply to be some of you might have heard of our artist in residence. We have a builder in residence program. It's just absolutely phenomenal. Here you can watch a video of the mayor of Boston, Marty Walsh. This is where I actually grew up in Massachusetts, Al, so seeing this investment in Boston, specifically in that part of the city, is just amazing. And then, once you're on the BuildSpace website, everybody, super easy to navigate, and you can, if you've got an awesome project you want to submit, feel free. If you are going to be in the area, we give tours on Tuesdays and Thursdays in the afternoon at 2 p.m. So you can request a tour here, or say your business is doing something phenomenal and you want to hold an event at the build space. Feel free, submit the event request. We love seeing all of this different stuff. So super easy to navigate, and it's a very large space. Can facilitate a lot of people. A lot of great learning can happen there. Another place where a lot of learning happens out on the internet is the Autodesk HSM forum. Now, if you look, the number of posts that we have here is just absolutely phenomenal. And you hear us talk about some of these level 70 users and some of the customers out there making their own YouTube channels. Well, really what's going on here is this is the Autodesk community. This applies to a lot of different products, but here we're focused on HSM. And if you ever have a question, chances are someone else might have had the same question that you have, and you can go here. And I know when Al isn't busy managing, product and whatnot, he's on these feeds. I know our CEO has been known to drop in on here. We can see Wayne, a lot of people that are working behind the scenes to make this technology so great. They monitor this site. Another great spot to go is
while you're here too, in the vein of today's webinar where it was kind of a shop talk about how some parts were made.
Yeah.
You may have noticed there's a couple sections on that forum. There's the support side that the support and our general teams are a part of. Actually, there's a couple support guys on our call today. But there's also a general machining discussion. So a lot of other machinists there, just how would I hold this part? How would you attack this part? You're going to find a vibrant conversation of help from guys like, I'm going to laugh because Rob is sending comments in here about level 70 users.
Yeah.
Guys like Rob are there and they're helping out. Seth is there. Neil Stein is there. Other users, I think Ben's on our call today. He's on there. So you got a lot of insight into how to attack a part. So don't think of the forum just as a place to get software help. Think of it as a community to chat with your other friends about how to attack a part.
Exactly. And then, when you've got an idea, say, hey, I'm working in the software. Man, it would be really great if I had X, Y, and Z functionality inside of here. Well, you can do a couple of things. You can always send us an email if you'd like, but the idea station is phenomenal. You can upvote your ideas for whatever you'd like. We're looking at an idea station for Fusion 360, but we have these for different products, and it's a way for direct customer feedback to influence product development. Absolutely phenomenal. I don't know any other CAD/CAM company out there that interacts with their user base like this. So just truly great stuff. And then, guys, you all know, I'm sure you know by now, that we supply a host of generic post-processors for free. And so you can access those inside the software. You can even go on our website, cam.autodesk.com/posts, and access those as well. And then if you need some custom work, or there's a post that you need that you don't see here, we have a whole group of channel partners that can supply those as a service as well. So you're not alone. You've got a lot of resources. And then here we've got Autodesk University. So if you found any value in these Friday HSM Hangouts and you want to come and learn directly from the people that put these together, a lot of times what you'll see, I know that Jeff JJ taught a course in the past. He just did a phenomenal webinar around surface finish. So if you guys aren't subscribed to our YouTube channel yet, please go out there and do that, because you'll get an alert when we update the channel. And we're updating the channel with instructional videos because, again, it's all about community. It's all about helping each other out and being successful. So just let us know what you need. And then AU, by all means, if you can manage a couple nights in Vegas, it's definitely worth the trip. And you can tell if, hey, look, if you're not going to make it to the States, we host Autodesk University all over the world at different times of year. So no matter where you might be tuning in from, whether it's Russia or the United States or Mexico, it doesn't matter. We got you covered. So just let us know if you have any questions.
Just a couple more comments on AU.
Sure.
First, it's a long time away, but we're trying to sort of set the stage for it now. If you feel like you have something to share to the other users there, reach out and let's start talking about that. You will get your conference pass covered as a presenter. On the same note, if you feel like you have something you can share in one of these Friday Hangouts, whether it be software tips and tricks like Rob and Lawrence did in the past, or you want to take a format more like today where CJ did a bit of a shop talk and talked about how he worked through attacking a part, and you want to have a more defined role in one of these Hangouts, feel free. Of course, we'll always be watching the questions and including you in the conversation that way. But whether it be presenting at AU or to the rest of the users on one of these Hangouts.
That's a really good point. Another great way to get Al's attention is Instagram. So if you guys have your Instagram handles for, just your personal self or your shops, whatever it might be, make sure you're tagging. What is it, Autodesk MFG? There's a couple of handles, maybe a couple tags that we can go over, Al.
I'm glad you mentioned that. Neil actually left a little early today from our Hangout today, but I saw a post on Instagram, which is last night, where Phil up in Canada was doing some 5-axis stuff on his Herco and asked a question on Instagram, and Neil posted a response on Instagram on how to get that going. So there's the forums, there's a vibrant Insta Machinist community that's going on, lots of stuff going on there.
Yeah, so engage with us on Instagram. I know it's crazy, but on our Teams Weekly Report, that is a section for a lot of us, and our manager wants to know, what are we doing on Instagram? How are we engaging with our customers?
Well, this comes back to the same, I don't want to belabor the point, but similar to what Matt was talking about with the policy around education, is to remove barriers and get access to the software. Yeah. Again, our policy around how we can help and support you is remove barriers, whether that be you reach us on the forum or all of our email addresses are firstname.lastname at Autodesk. If the Instant Machinist community is where you are, that's where we'll try and be to help you. These Hangouts, if there's other ways you think we can build a better connection between you, our user base, and us on the software side, let us know. It's about removing barriers and working together as partners between us developing the software and you using it.
Great. Well, on that note, Al, I think I need to remove one more barrier and let everybody go. Thank you so much for joining us for your weekly Friday HSM Hangout. My name's Jordan Roberts. We got Al, we got Wayne, we got CJ, we got Matt. Huge thanks to everybody that puts these together. Huge thanks to all of our customers that join us week over week. We do know who you are. We take a look at the list of attendees, and we love seeing the same name every week. If you know somebody that's interested in machining and you want to invite them to this, we would love for everybody to refer a friend for next week. And if you haven't engaged, follow us on Instagram. We'll follow you back. And if you're doing something amazing and you want us to promote maybe something that you've done in HSM technology, just let us know. Send us an email, whatever it is, tag us in it, and we'll see what we can do about helping out. So thank you so much, everybody. Al, thank you as always, and the rest of the team. Really appreciate it, and we'll see everybody next week.
It's fun. It's always a highlight to my week hanging out with you guys. So.
He's paid to say that.